More dependent events. Use the details about the game to answer questions below. In a board game, students draw a number, do not replace it, and then draw a second number. Determine the probability of each event occurring. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 cards. Drawing an odd number, then drawing a 6. We have 1, 2, 3 odd numbers out of 8. Since it's dependent, my denominator decreases by 1, and a 6. 1, 2, 3. No simplifying can be done, so we multiply top times top, bottom times bottom. We get 9 out of 56. Drawing a 2, then drawing another 2. We have 1, 2 2s out of 8. So we've taken that 2 out, so we now only have 7 cards total and only 1 2. We can simplify here. Divide both of these by 2, I get 1 over 4. So I have 1 times 1 equals 1, and 4 times 7 equals 28. For number 3, drawing a number divisible by 3. That means we can divide 3 into it. Well, 6 works, and we've got 3 of those, and a 9. We've got 1 of those, so that's 4 out of 8. We took one of those cards out, so we now have 7, and then drawing a 1, we have 2 of those. We can simplify here. Well, I know 4 times 2 equals 8, so these are all now 1s. So 1 times 1 equals 1, and 1 times 7 equals 7. Or you can do it the other way. 4 times 2 equals 8, and 8 times 7 equals 56. I can divide both of these by 8, leaving with 1 over 7. Okay, this one we have drawing a 1 and drawing a 6. 8 cards, we have 2 1s. We now have 7 cards and drawing a 6, and we have 3 of those. I can simplify this by dividing both of them by 2, gives me 1 4. 1 times 3 equals 3. 4 times 7 equals 28. Drawing a prime number. A prime number is any number divisible only by itself in 1. 1 is not included in that. Not prime, not prime, not prime. Prime, not prime. So I have 2 prime numbers. A composite number is anything that is not prime minus 1. So that's 1, 2, 3, 4 out of 7. And again, I see both of these are total. Well, multiplied together, I get 8. 2 times 4 is 8. So that means all of these are now 1s. 1 times 1 equals 1. 1 times 7 equals 7. Or you could have done it the hard way. 2 times 4 equals 8. And 8 times 7 equals 56. And then divided both of these by 8. Drawing a 9 and then another 9. Well, we have 8 things, 1 9. We have 7 things, but that 9 is gone. So now I don't have any 9s. So that gives me 0, because anytime you multiply by 0, you get 0. Drawing a 9, then drawing a number divisible by 1. I have 1 9 out of 8 things. I now have 7, but every number is divisible by 1, so I have 7 out of 7. 7 divided by 7 equals 1, so anytime you multiply by 1, you get the same thing. So divide both of these by 7, I get 1 and 1. Drawing an even number, then drawing 1. I have 1, 2, 3, 4, 5 out of 8 even numbers. Now we have 7 cards. And then a 1. I have 2 of those. I can divide both of these numbers by 2. So now I have 5 times 1 equals 5. And 4 times 7 equals 28. You could also do 5 times 2 and get 10, 8 times 7 and get 56, and then divide both of them by 2 to simplify and get 5 out of 28. Drawing a 6 and then drawing an odd number. I have 3 6s out of 8. I now have 7, and an odd number would be 1, 9, and 1, so that's 3. No simplifying there, so I get 9 out of 56. Letters, the word December and bag not replaced. So we have 8 numbers not replacing, so we get 7. A C, there's only 1. An E, there is 3. Multiply, we get 3 out of